Sometimes you really wonder about the content generation powers of all of these vision language models, large language models, and this new project, FIFO-Diffusion, is one of those. In this video, I am going to introduce you to this FIFO-Diffusion and why this looks so promising. Before I introduce you to this project, let me play this video, especially this one, which is from my city, Sydney. So let me play it and just look at it. So this is world famous yearly fireworks on Sydney Harbour Bridge. It is spectacular and looks so real. And this is the video which has been generated by a model and just from text. And the text was this, that a spectacular fireworks display over Sydney Harbour 4K high resolution. And look at this image. Let me go back. Amazing stuff. And these are the ferries which travel under the bridge and then across to the Parramatta River and towards all the places. Amazing stuff. And then you see that there is also the Opera House on the left of the bridge, and then you can see Sydney's skyline in the far. Amazing stuff. Of course, it doesn't look that real, but this is just a 1K frame long video. Let me play another one. So you see these are the penguins. Amazing stuff. This looks way better. And then look at this one, looks so real. Amazing stuff. I will drop the link to this project page in video's description. Go through it and you'll be surprised to see the quality of this new project. The thing is that all of these diffusion probabilistic models have achieved significant success in generating images, and we have seen it on the channel with numerous channels. On top of the success in the image domain, there has been rapid progress in the generation of videos. But despite of this progress, long video generation still lags behind compared to image generation. And that is why my channel is still going on. So let's see how long that lasts. Anyway, one reason of this lag is that video diffusion models or VDMs often consider a video as a single 4D tensor with an additional axis corresponding to time, which prevents the model from generating videos at scale. And that is quite an important finding. An intuitive approach to generating a long video is autoregressive generation, which iteratively predicts a future frame given the previous ones. But in contrast to the information-based models, diffusion-based models cannot directly adopt the autoregressive generation strategy due to the heavy computational costs incurred by iteratively denoising steps for a single frame generation. Instead, many other projects adopt a chunked autoregressive generation strategy which predicts several frames in parallel conditioned on few preceding ones, consequently reducing computational burden. And you will see that throughout this project, and let me play a few more videos and you'll be surprised to see the quality. For example, look at this one. This is what I was talking about. Look at this line one. Look at the head movement. So these approaches, not this one, but the previous ones, are computationally tractable and it often leads to temporal inconsistency and discontinuous motion, especially between the chunks predicted separately, since the model captures a limited temporal context available in the last few, only one or two in practice frames. That is where this FIFO diffusion shines. It's a proposed inference technique that realizes the long video generation even without training, and that is the most important part of it. And this is all without training. Look at the motion. How good is that? Look at this motorcycle. How real it looks. And then look at this one. This is a comparison. This is a FIFO diffusion on top of Video Crafter 2. It just takes it to another level. So this technique, as I said, realizes the video generation without training. It facilitates generating videos with arbitrary lengths based on diffusion model for video generation pre-trained on short clips. Also, it effectively alleviates the limitations of the chunked autoregressive method by enabling every frame to refer to a sufficient number of preceding frames. This approach generates frames through diagonal denoising in a first in first out manner using a queue which maintains a sequence of frames with different monotonically increasing noise levels over time. At each step, a completely denoised frame at the head is popped out from the queue, while a new random noise image is pushed back at the tail. Diagonal denoising offers both advantage and disadvantage. Noisier frames benefit from referring to cleaner ones at preceding diffusion steps, while the model may suffer from training inference gap in terms of noise levels of concurrently processed frames. That is where this research has also proposed latent partitioning and look ahead denoising to overcome the limitation and embrace the advantage of diagonal denoising. And that is why I think that is going to be embedded very soon. Let's play this one. There you go, you see how real it looks. And latent partitioning constrains the range of the noise level in the noisy input images. So, all in all, amazing project, and I'm playing different videos just for your reference. So, this FIFO diffusion through diagonal denoising, which is a training-free video generation technique for VDMs trained on short clips. This approach allows each frame to refer to a sufficient number of preceding frames and facilitates the generation of arbitrarily long videos. How good is that? And they also introduce latent partitioning and look-ahead denoising, which enhances generation quality and allows parallel inference and demonstrates the effectiveness of those two techniques theoretically and empirically. And these experiments on four strong baselines, regardless of unit architecture, show that FIFO-Diffusion generates extremely long videos without degradation on quality over time and presents natural motions. Amazing project. Really cool. So I could go on and on playing videos here, but the crux of the matter is that it looks so dynamic, so real. Plus, it is just a start. I know the videos are not that crisp, that vivid. They don't really look that realistic. But as I said, it is just a start. Let's wait for some more time. But I think this is going to be huge. Just add some audio into it. Just add some text onto them, and sky is the limit here. I will drop the link to this project page in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please do me a favor and share it among your network as it helps a lot. Thanks for watching. And look at this one. Amazing stuff. Looks so real.